In this video, we want to talk about the graphs of the other trig functions. We've talked a lot about the graphs of sine and cosine and how we change the period and amplitude and shifting it left or right. What we want to look at are the graphs of tangent, secant, cosecant, and cotangent. Now, luckily for us, these are really based on sine and cosine. So that makes it a little bit easier for us. If we know our sine and cosine well, that should be easier. At this point, you shouldn't even be doing this video unless you've already passed the quiz over the reference angles, or other trig functions, and the graph. So we need to finish that quiz before we even get to this video. But once we've done the quiz and you've shown you've known that, we're ready to move on. Now, the first two that we're going to look at are cosecant and secant. Now, we know that cosecant is equal to 1 over sine. And secant is 1 over cosine. And if you look at their graphs, you can kind of see it. Here's what I mean. This is cosecant, these u's. If I graphed sine, now it's hard to tell the scale, but here is sine. Starts at 0, ends at 0. Cosine would look like this. So you can see secant and cosecant basically are these U shapes that come off the peaks and valleys of sine and cosine. Now what happens is anywhere sine is 0, like at pi, you get a vertical asymptote because you can't divide by 0. So you get these vertical asymptotes in both of these graphs wherever sine or cosine is 0. And that's going to be true for tangent and cotangent also, because we have these fractions. So to graph secant and cosecant, all we really need to do is graph sine and cosine. Now you can see, just like sine or cosine, the period starts at 0, goes to 2 pi. It's almost the same as sine or cosine. So if I want to graph secant of 2x, what I want to do is I want to graph cosine of 2x. So cosine of 2x doesn't change my amplitude, changes my period to 2 pi over 2, which is pi. So cosine would be here to here, assuming we already know how to do cosine. And there's my graph of cosine. Now, my secant just comes off the peaks and valleys of that. So what I'll do is where it's 0, I have vertical asymptote, so I'll do some dotted lines for vertical asymptote. And then I have these u that comes down like there. Here we only have half of it. I'll explain that in a second. And there is my graph. Now let me go back a second. Notice for cosine, 0 to 2 pi is over here. I have half, the full, and the half because of the way cosine is. That's okay. Now, understand, the red is not part of the graph. The vertical asymptotes are not part of the graph. However, it's okay if you have those in there. We need to use those to help us draw the graph. So I don't care, draw it lightly. If that cosine graph's in the middle, just understand those blue lines are what's important. So this one, cosecant. Now, we know our amplitude is 2 for our sine, and I'm shifting it to the right pi over 3. So I graph sine. Regular period. So there would be my sine dots. Now I got to move everything to the right, pi over 3, which is 2. This is exactly what we just did in the last homework. And I put those dots in the wrong spot. Let me try again. It didn't look right, so we go here, here, here. That looks better. Now I move them over to the right, 2. So now my graph of the sine is like that. And then I do vertical asymptotes anywhere it's 0. And then my graph are the u's that go off the peaks and valleys. So what you see in red, I'll pull the blue away. Oop, don't want to do that. Let's pull the blue away. The red is our cosecant. So really, if you're able to graph sine or cosine, it's just an adapting that to the graph. Okay. So that's tangent and cotangent. Now these are a little bit harder. They're not to use. Now remember, tangent is sine over cosine, and cotangent is cosine over sine. Now, that will help us for our vertical asymptotes. Because anywhere sine is, anywhere cosine is 0 at pi over 2, at 3 pi over 2, that's where I have a vertical asymptote and tangent. For cotangent, where sine is 0, 0, and pi, I have a vertical tangent. So think about where those bottoms are 0 to give you your vertical tangent. Okay. And then when we draw our graph, all we're really going to do, all I'm interested in, is you get the 0 in the right place, which is where sine is 0 or where cosine is 0. Tangent is always going up. Cotangent is always going down. And that's the extent of the graph. Okay. Notice these have a period of only pi. They repeat sooner than secant, cosecant, sine, or cosine. Okay. So let's look at tangent of x plus pi over 6. Now what this is going to do is it's going to move my tangent to the left pi over 6. Now tangent has a vertical asymptote at 1/2, or negative pi over 2 and pi over 2. And then I can draw a tangent, just kind of comes up, goes through, and like that. The main points we're looking at are the vertical asymptotes and where it's 0. And I'm going to move everything to the right, or excuse me, the left, pi over 6, which is one line. So I move that over one line, I move that over one line, and I move that over one line. And there is our graph of tangent. All right, we're ready to do the homework for Trig Graphs 3.